Hey everybody, how's it going? Stoner Dave here, and I want to talk today about a few components that some people kind of confuse with each other, even though they are completely different in all ways, shapes, and forms. Okay, the only thing they really share in common is that they are silicon based, right? That's it, semiconductor based. Not even necessarily silicon, because transistors come in germanium. So you got a lot of different things, right? So today I want to talk about voltage regulators and transistors. Now, transistors, it's not really a lot to go into about transistors, right? I've already really demonstrated transistors quite a bit, right? But just to catch you up a little bit, they come in essentially two varieties, right? You have the BJT, bipolar junction transistor, and the field effect transistor, or the FET, F-E-T, field effect transistor. That's the two main ways you'll find these. Now, like I said, they come in a variety, right? Silicon and germanium, right? I got germanium in this little volt here. Here, I'll show you the germanium one. Germanium transistor. I can always spot this guy in my toolbox here because of the metal casing. The one that isn't so easy, usually in this case it is the field effect. See, this one's easy to spot because this kit of them took a whole bunch of surface mount variety, put them on a little board, and attached them to these little legs here. And that's a field effect. That's a field effect, but I've got others. Right here, right? This is a field effect transistor. And this is a bipolar junction transistor. Same fucking body casing, but so the only real way to really tell them apart is to look at the model number on the back of them and see what that says. Now, in this case, what did I grab? All right, so this is the field effect. I'll put this over back with the field effect ones. And this is a bipolar junction. Now, it's like it's 2N5401. Now, honestly, that number tells me nothing about this transistor at all. But I do know it's a bipolar junction transistor because I pulled it out of a slot that said bipolar junction. I did not look at what type it was. Let's see, what was that again? Fucking high. N5401. 2N5401. So it happens to be a PNP type. So jumping in transistors is kind of a hard thing to do if you don't understand diodes, right? Now, I'm sure that most of you know what a diode is, right? Diodes come in different varieties too, and I'm not going to go into all of those, but essentially, the most basic of the diodes, this guy right here. So 1N4148, it's a switching type diode. Doesn't really matter. It's a semiconductor diode, and there's two types of material in this diode. It's an N type and a P type. So, funny enough, the N type when forward biased, the N-type is the type that has this little black indicator that, in this case, would go towards ground to forward bias it. And this side right here, clear side, goes to the positive side, the P-type. And that's it, right? P for positive, N for negative. That's the type, right? It's not really the type. The N and P, I don't really know what the hell they mean. They just have always called it a PN junction. P-type and N-type, and it just so happens forward biased. P-type is towards positive and the N-type is towards the negative, and it'll allow current flow. You put it in reverse bias though, and it'll block current until you reach any kind of a bias voltage, which is usually pretty high and would be something beyond putting something backwards. So these transistors is a PNP type, and what that means is that it's got a P-type, then an N-type, and then a P-type. Kind of sandwiched together. The N-type is between the two P-types, right? P-types. All right, so now, what that means is this thing, when hooked up, will have different functionality than just the diode, right? The diode will either block or conduct, depending on if it's forward or backwards biased. Well, this guy, he's got the N-type and the P-type, and what happens is when you put these things together in the right proportions and you apply a voltage to one side and the other P-type to the opposite voltage, this is like, it's the opposite type, and you got to put it in such a way that current will be able to flow once a small voltage or small current gets applied to the middle type, right? In this case, it's PNP, so it's a positive, negative, positive, right? Or it could be the other way, positive, negative, positive. But what you want to do is you want to have it so that it's positive on one and negative on the other, right? And it does depend which is which, N-type and P-type, PNP and NPN. The type determines which way you want the voltage to be kind of going. The schematic symbol has a little arrow that'll tell you which way the current should be going for traditional current flow. That's from positive to negative. So arrow points to the negative, and you get yourself your working transistor, right? Okay. Carrying on too much, right? So if the arrow is pointing down, then that means that your negative voltage, or what we typically would have as a ground connection, will be at that end, right? And if it's pointed up, that means that the negative voltage, what we usually consider ground, but sometimes we use a negative voltage, but will be up at the other end. It's just a reversal of the polarity. It's not a big change in the diodes, in fact, or the transistors. In fact, for each one of these, there's an opposite. For this one, 5401, so looks like 5551 would be my opposite to this guy, right? And that will allow you to create different types of amplifiers and switching circuits, and that kind of defines the transistor. Transistor is capable of really doing one of two things. It'll act as an amplifier, and you can put it with its opposite or sister pair to create a push-pull type amp or differential type amps, whatever type of amplifier you want to make. You know, you can build it with these different types of transistors. Or you can use these transistors to make switches. They turn off and on, making digital signals easy to process. And in fact, all modern technology is built off of these things. All right. Good for you, good for you. The other option is the field effect, which is kind of the same thing, just the construction's a little different. See, instead of having a N-type and a P-type that are sandwiched together, instead what you have is an N-type and a P-type where one type is kind of wrapped around the other. So it's one type, and then the middle, and it's weird the way that it works, but because things are working at this such a small level, and these phenomena occurs when current goes through things, and kind of creates a little. It's too much for one fucking video, right? But they are interesting, and if there's enough people give a shit about this, maybe I'll talk about it in the future. But let's just say that they operate very much like each other, but in a different way. All right. Later on, I'll do some videos showing some neat electric things and different ways that you can do them. So that'll be fun. But anyways, let's get on to the next part of the show, the voltage regulator. Okay, so before I go into the voltage regulators, I want to talk a little bit about their schematic symbols, or at least get you familiar with the different schematic symbols that you'll see for transistors and voltage regulators. So first, let's look at a few transistor schematics, okay? Okay, everybody, so this is the schematic symbol for the PNP type bipolar transistor. It's supposed to say bipolar junction transistors, commonly known as a BJT. But as you can see here, this is our collector, our base, and our emitter. In this case, you see this arrow is pointing towards the middle. This tells us it's a PNP. Now, what this is telling us is also the current flow direction. So, if we have a positive voltage here and a negative voltage here, a small signal coming in here will allow a large current to flow across here. Now, this is a common application of an amplifier, and that's what these things are used for. Now, another thing happens is as you go through the signal, if you go too high above or too far below, you'll enter what's known as saturation or cutoff. Saturation is basically you reach the limits of how high up it'll go, and you just get a constant saturation current and a very low saturation voltage. Or if you're dealing with this particular guy, you'll get what's known as a very high saturation voltage here. These are the basis of all digital communications and electronics, is this guy right here's ability to go into saturation and cutoff. So they either amplify or they work as a switch. PNP bipolar junction transistor. Okay, and so next, let's talk about the other type of bipolar junction transistor. Okay, so this is the NPN bipolar transistor. Again, bipolar junction transistor, you can also see it over here. NPN silicon BJT. This is all the details of it. Not really too important for our conversation. Basically, you put a positive voltage here and a negative voltage here. Signal comes in through here, gets amplified. You get an inverted signal here or non-inverted signal here. But it's amplified depending on how you set this thing up. A lot of it is going to be calculated based on the numbers right there. But we're not going to go into that right here. Basically, all you need to know is that this guy is the opposite polarity of the guy we just looked at. But N-type, P-type, N-type, bam, boom. And you see how it works with transistors. All right. Cool. All right. So Now you've learned about the silicon bipolar junction transistor. The germanium is the same thing, you know. NPN, PNP type, depending on what's available. I've only got the PNP type here. There, for some reason, didn't have an N type, or the NPN type, but it's okay. You know, like I said, it's just the opposite polarity. Nothing major going on with that. But that's only one type. Like I said, there's two types of two basic types. There's other types, but they're not as common, right? There's phototransistors, there's IGBT transistors, and I can't even think of all the other ones, right? But they're out there, right? Depending on the need, somebody will come up with a way to use a transistor for it. Anyways, the other type, common type, is the field effect transistor. Now, there are a couple of different types of these, right? There's MOSFETs, there's JFETs, and of the MOSFETs, there's enhancement and depletion mode. And for the field effects, you know, I don't want to ruin all the fun. Let's just take a look at what we have here. I don't honestly have a lot of field effect transistors readily available. I think I've got MOSFET and the JFET. Sorry, I don't have the opposite orientations of them, but as you'll see from looking at the schematics, you can kind of put two and two together, right? All right, let's get you those schematics right now. Okay, so folks, this is the schematic symbol for the N-channel JFET. So this means junction field effect transistor. It basically means that this guy is making a junction through there. These guys are almost connected. This guy right here, he kind of pinches them together. So that's really all it is. It's really weird the way that they show it, but N channel just means that the channel is made out of the N type and these guys are made out of a P type. That's it. That's your N type. All right. Pretty simple, really. They do the same job as what the silicon ones do. They just do it a little differently. But it's the same thing. It amplifies the signal. If you have well, in this case, it's symmetrical, right? So you can have positive on one side, negative on the other side. And it doesn't really say. See, either one of these could be the source or the drain. Doesn't really say, but typically, in this case, the drain is the positive and the source is the negative, and it's because this guy right here is the, or no, wait, it's backwards, sorry. Because this is N type, this is the negative and this is the positive. Typically, but again, it doesn't really care as long as one's opposite of the other one. This guy right here, it's really complicated for me to explain it, but that's it right there. And this little arrow tells us the polarity. If the arrow is facing the other direction, it'd be the other way. The big difference between these guys, the arrow is actually attached to where the signal comes in rather than being attached to where one of the signals goes out. In either case, this is your field effect transistor. Cool. All right, folks, there's only one other type of transistor I want to show you before we move on to the voltage regulators. This is the MOSFET. MOSFET means metal oxide semiconductor field effect transistor. It's a mouthful, right? So we just call it MOSFETs. But it's basically the same thing as the JFET, just a little bit of a different construction is all. But I'll show you this one, and it's got a little bit of an added benefit to you that I'll talk about a little bit as well. All right, folks. This is the P-channel enhancement mode MOSFET. So it's not much different than the JFET, right? P-channel, talking about this right here. See, the arrow is pointed this way. The other one had it pointed that way. That's your big arrow, right? Gate, drain, source. So this is this is similar to, like I was saying, positive voltage here, negative voltage here. Signal comes in here and it gets amplified, either read from here or here. Now, this little guy right here is a really interesting thing here. This is a flyback diode. So that means I got the voltage backwards, because this side must be the negative and this is the positive. Otherwise, this would be forward biased and current would just flow through there. Wouldn't want that. But in any case, it's essentially the same thing, just with a metal oxide semiconductor rather than silicon and or germanium. Although germanium is a metal oxide, but never mind, right? Doesn't fucking matter. This is the MOSFET. It's enhancement mode. That's, again, part of this is the definition of that. That's all it is. It's another mode, and it can be used to either switch off and on or to amplify the signal. That's it. MOSFET. Okay, folks. So this is the moment you've all been waiting for. You could finally see the big difference between a voltage regulator and a transistor. I know that some people think they're the same thing, right? That we just go around talking about voltage regulators like transistors, and transistors like everything with 3 terminals is a transistor. And, it's just one of those things. Now, I have here a sample of a voltage regulator, right? This is it. This is a voltage regulator. This is a transistor. Now, I could see if somebody were just looking at a schematic, at a board that somebody already put together and everything, and they just put it together according to the what they could see on the board without following any direction or whatever. I could see somebody confusing these two things for each other. But when you see the schematic symbol and you say, well, this one would show up as one of the schematics I just shown you, and this one is going to show up as the schematic I'm about to show you, well, you can understand how nobody would see this on a board and think transistor. They would say voltage regulator. Because when people who know about electronics talk about electronics, we talk about the electronics as the component that they are, you know? We don't pick up a capacitor and say, oh, this pack of resistors, right? Well, they're passive, right? And common for a resistor to be a passive thing, but we don't do that because a capacitor and resistor are 2 different things. Well, likewise, this voltage regulator and this transistor are 2 completely separate different things. So we wouldn't talk about them like they were the same thing. It's not a shorthand. We're not sitting there talking about the difference between a Les Paul and a Rondo fucking LP 500, whatever, right? We're talking about the difference between a voltage regulator and a transistor. They do 2 separate different things. Transistor will amplify a signal or control the logic state of a system, right? They can turn off and on, 1 or 0, or they can amplify and create a bit of gain, right? So one of the distortion pedals that I built, or I should say overdrive pedals that I built, was powered, or the amplification within it was just a single transistor. It's a single transistor overdrive. I thought myself, one of my greatest things I'd ever accomplished, right? But no. That being said, right? Let's take a look at this schematic symbol so you can see for yourself just how fucking stupid you'd have to be to call one of these a transistor. All right, folks, this is it. This is the schematic symbol for voltage regulators. Voltage regulator. In, out, ground. So you have a voltage, whatever your voltage is, right? Let's say this is a 7806, right? So you need like, you need like 8 volts over here, give or take. 8, maybe 9 volts here. Going, there's usually a capacitor that goes between here and here, right? Round about 8 volts coming in here. Then you get your 6 volts out here. And of course, there's another capacitor that goes from here to here. Common ground. And this is your output, your regulated voltage. That's it. That is the voltage regulator. How the hell somebody could see this on a schematic and say, oh yeah, that's a transistor, is beyond me. Because that is definitely not a transistor. And the in, the out, the ground, those are the pin names, right? Pin 1, pin 2, pin 3. I know, it seems really dumb. What do we have here? 7805, look at that. Oh, yeah. Do we have a dropout voltage? We do, look at that. 1.43, which means that we need at least 6.43 volts going into this thing. That's all dropout voltages. How much above the output voltage do you need your input voltage to be able to keep the voltage going? That's it. All right. I'm sure I missed quite a bit. I'm sure there's some things out there that people are confused about from this video. For those things, I apologize. I'm trying to do this really quick, and I'm trying to not get super bogged down in the details. There's a lot of fucking details that go into these things. As far as where I'm getting these schematics from, well, DCA Pro. Best fucking investment of my life, about $120. Will identify and test just about any 3-terminal semiconductor material component device. All right, folks, there you have it. Transistors and voltage regulators described, identified, discussed in great detail. Almost a half-hour long video. And, I think that when this is watched, some people out there are going to realize that, hey, maybe this Dave guy knows what he's talking about, right? Other people will just watch the first 5 seconds of it and then try to write some kind of a disingenuous comment, trying to berate me because I'm not friends with Detroit Wrecker. Oh, poor Detroit Wrecker. Doesn't know the difference between a transistor and a voltage regulator. And you've seen the things. This schematic symbol looks nothing like a transistor, right? These things are so far removed from each other that they go to great extenses to make sure that you don't think that this component is a transistor. They don't want you to call it a transistor. They want you to call it a voltage regulator because it's regulating voltage. It's not doing the job of a transistor. Oh, man. I don't know what else can be done for folks like Detroit Wrecker, but I can tell you one thing, right? Somebody asks you, what kind of a guitar do you have, right? So it says, what kind of a guitar do you have? Well, they're not asking you what the style of it is. Nobody cares what the body cutout is, because people can see that, right? There's really only one thing that they can't see when they look at your guitar from any distance, Alright? Hope I wasn't just showing you my ass. I remember what happened last time. People got really hurt by that. So, this is my actual guitar. Right? Look at all that dust on it. So, like I said, I'm not a guitar player. But I did play guitar for quite some time. You can see some evidence of wear right there. Got the little pick guard there. You can see some little evidence of wear right there too. Taking this off and putting it on a few times because, you know, it's really nice without it, but I like the black on black that this thing has. That's why I got these EMGs in there. And you can see a little bit of a usage on there and everything, but this is my actual guitar. And somebody asked me what kind of guitar I have. They're asking me what's on the fucking headstock. That's what they're asking about, right? Nobody gives a fuck about what the body style is. You tell them a Les Paul. Les Paul doesn't really mean anything, right? Les Paul doesn't mean anything. You're just saying what you wish was on the headstock. Which, in my case, guess what? That says Les Paul. So, somebody asked what kind of guitar do I have? I say a Les Paul with EMG 8185s. I'm not lying. I got a Les Paul with EMG 8185s. Now, if somebody asks me, really, I'll tell them I have an Epiphone Les Paul with EMG 8185s. Because when somebody asks, what guitar do you have? They're asking you, what's on your headstock? What kind of pickups do you have? You know, typically, you know, I mean, in this case, right? I say I have an Epiphone Bullseye Zach Wild Custom. Now look at this, right? Somebody asks me what kind of guitar I have. I say Epiphone Bullseye Zach Wild. Now, when somebody asks what kind of amplifier do I have, I don't tell them I've got a single practice amp with a 12-inch speaker in it, 15-watt practice amp. No, I tell them I have a crate GTD 15R, or I might say I have a Marshall MA100, right? Because those are the amplifiers that I have. Now, somebody asks, what kind of amplifier they have? They're not saying, do I have a half stack or a full stack, or do I have 4x12 or 2x10 or 4x8 or whatever? No. All they're asking is, whose name is on your fucking amplifier? That's what they're asking. If you feel that you have to go into the nature of, it's a half stack, it's a full stack, it's a quarter stack, you're not answering the question that's being asked. You're avoiding the question being asked, because you're being asked, what kind of amp do you have? Not, what's the speaker configuration of your amplifier? And if by chance you were asked the speaker configuration of your amplifier, would you really just say it's a half stack or a full stack or a quarter stack or eighth stack or whatever the hell you call a fucking practice amp? No. If you were asked your speaker configuration, then you'd be saying, well, it's a 4x12 half stack, or a 8x12 full stack, right? Or two 4x12 stack, right? So you would actually tell both of the things. You'd say the speaker configuration and half stack or full stack, because let's not get fucking confused. There are fucking configurations that are called a full stack that have not two 4x10 cabinets or 4x12 cabinets, but four 4x12 cabinets. Yeah, you'll see them when you go see big bands like Metallica or Slayer or any fucking buddy who fucking does real fucking shows. You'll see those big ass fucking full stacks, and a lot of times they're called double stacks. But yeah, if somebody asks you what you're playing through as far as your speaker configuration, well, that much I've never heard anybody ever ask that, but yeah, typically you'd say a 4x12 or 4x10, right? 4x12, 4x10. They want to know how big are the speakers inside your fucking half stack or full stack. So yeah, you share that information. That's called answering questions. The fact that you don't get that, or you seem to be bewildered by the fact that people would include those details when asked those questions, it's kind of bizarre, right? I mean, I don't know, man. I don't know. I'm just saying. Right? If those are the questions that you're being asked, well, there's a certain way to answer them, right? Did I leave my battery on the coffee table? Oh man, this is the second time it's gonna go hit this vape, and I don't have the battery with me. Fuck. Oh well. Until next time, people. Take a moment to consider what these things are and why we have them and what they're used for. Because honestly, you're listening to somebody like Detroit Wrecker and you're trusting him for advice about electronics. Just think that he should have some basic knowledge of electronics. Just food for thought. All right, folks. So it's been a long video, and as you can see, it's the next day, right? But I'm going to end this one, and right here is this little demonstration of something that I'm kind of working on as a fun thing. And I'm going to do a little video talking about this next, so peace out.